Thank you, Dr. Nandana. So, greetings to one and all present here in this particular tutorial. My name is Pooja Harde. Dr. Jain is having some audio issue. That is why there will be some time. Till then, we will start with this. We will start with this tutorial. So, to introduce with myself, my name is Pooja Harde. I am working as a JRF in NIT Kurukshetra under the supervision of Dr. Sarika Jain. So, just let me share my screen so that we can start with this today's tutorial. Can you please confirm that whether my screen is visible or not?
Yes, it's visible.
Okay, thank you. So today's tutorial is about how to build a domain-specific linked open data applications by Dr. Sarika Jain, Dr. Nandana, myself, Pooja Harde, and Ankush Fish. So the aim of this tutorial is what were the traditional data techniques that we used to use previously, and how it has evolved and changed into the semantic web and linked data, and how it has changed the scenario on the scenario of the World Wide Web. And then we will also see that what is the role of the semantic linked data in the current scenario, how it helps the humans and the machines to get the knowledge and use that particular knowledge to infer the reasoning and process further. So the course of action for this particular tutorial is building the domain-specific linked data applications. So the agenda for today's tutorial is we will start with the first module where we will talk about semantic web vision as motivation for the linked data. Then we will have the second module where we'll talk about the knowledge modeling. We will also do some hands-on session about that, means how do we create that, how do we create knowledge modeling and how do we use it. Then after these two modules, there will be a short 15 minutes of break, or we can also have the discussion and the QA if anyone is having any doubts. And then the third module is about in the third module we will talk about what is the RDF creation, means how do we create the linked data. We will also see the demo regarding the same. And in the fourth module that will start from 12:10 p.m. we will discuss regarding the Sparkle queries. What are the Sparkle queries, how we use to access the data if it is in the RDF format, and we will also see the demonstration regarding the same. So in this way, this is the agenda for the today's session. So we'll start with the first module. In the first module, we will talk about what is the semantic web, what is linked open data, what is the semantic web tech stack, and the case study. This case study is basically the motivation that we have got to work on the linked data and the semantic web. So we will discuss also about same, and we will also present our work that we have done. That is nothing but the Olligraph. Olligraph is nothing but the Olympics linked data. So to start with, what is semantic web? Some 3 decades ago, we used to use the internet or the World Wide Web, where we were having a lot of documents. So basically, we used to call it as a web of documents. So you can see in the picture on the left-hand side, there are so many documents which are connected with each other. But as the time has evolved and due to the latest evaluations in the technologies, we have come up with the different versions of the web. Like previously, we were using the Web 1.0. Now then it came to Web 2.0. We were having then Web 3.0, and now we are also moving towards the Web 4.0 and 5.0. So we will also discuss what these particular web versions are. So as we are evolving with the technology, from the traditional web, where the document is the main source for getting any information, we are shifting towards the semantic web, where not only the humans can read the content, but the machines can also be able to infer the knowledge from the data that is already present on the web, and how it can transfer that data from one place to another. It can basically gain some knowledge from it, and it can do some assumptions or the analysis regarding the same. So as the picture itself says that on the left hand side the documents are interconnected, but on the right hand side we have the kind of a web where you can see the documents are having the 3 particular entities, the subject, predicate, and the object. These are nothing but
मैं तुम्हें अनम्यूट ही करने की कोशिश कर रही हूँ, तुम्हें होस्ट बना रही हूँ.
hello. Hello.
सुन रही हूँ, बोलो.
Okay. So as we can see on the right hand side picture, here the documents are not interconnected, but the data that is there inside the document, that is interconnected. So you can see that these particular documents are connected to particular node which is there, a particular node which is there present in the linked data. So this particular is nothing but the web. So what happens, it gives us the access to the data instead of only the documents that we used to have previously. So now if we want to talk about what is the difference between the traditional web and the semantic web, we can see that the traditional web we also used to call it as a web of documents, but for to the semantic web we called it as a web of data. So here the data is the important component instead of the documents. And in the traditional web we used to link the documents. The structure used to be the unstructured data, means it will be in the form of a PDF files, or it will be in the form of the web text, it will be in the form of a CSV or something like that. And then the knowledge or the semantics that used to be there in the traditional web, it used to be implicit. If anyone wants to find, if anyone wants to gain any knowledge from the data that is available on the web, only humans can do that particular thing, not the machines. So it was basically for the human consumption. That web of documents was for the human consumption. But when we talk about semantic web here, we are not only talking about the documents, but as it can say that you can see that it is a web of data. So here the real objects like the places, the persons, or the things, they are interrelated, they are connected with one another. So here the links are between the things basically, and previously there were the links between the documents. So this is the difference between the traditional web and semantic web. So here in the semantic web, the data will be the data will be in the form of a structured data. So previously in the traditional web, the unstructured data is nothing but the text in the form of web text or any PDF files if we want to download it, something like that. But here the structured data means we will use a particular format in which in the way we used to store the data on the web. Then here, as we are using, as the main focus is the data, so the knowledge there will be the explicit semantics that will be mentioned, and this particular data will be useful for not only the humans but also for the machines. So you can see there is a small diagram on the right hand side. This is the same diagram with some more components. Like we have started with the web 1.0 in something 1990s, where we were having the static web and the shopping cart things, and it used to connect the information. But as we have evolved, we are having the web 2.0, where the people used to connect via the social web. So means the social web came into the picture in web 2.0, like the Twitter, YouTube, and Facebook. So here in web 1.0, we were only having the read-only web, means we were only used to read the contents that were present on the web. But in web 2.0, we were also having the rights to read, write, and publish the contents on the web. So as then we move further in web 3.0, it is nothing but what we call it as a semantic web. So here it not only connects the information and the people, but it also connects the knowledge that is there. And what do we require for this particular thing? This is the main content that we are going to discuss in this particular whole tutorial. So, and next, as we will go further, we are also having the web 4.0, 5.0, and much more to come, where we are connecting the intelligence. We are inferring the knowledge from the data. Like example, there are the Facebook's open graph, protocol, Twitter's annotations, and so on. So now, as I hope that we must have got the idea regarding what the semantic web is all about and how it is different from the traditional web. Now we will talk about the linked data. So basically, semantic web is nothing but it is a vision of web of data. And how do we achieve that web of data? We require the linked data for that. So what basically the linked data is all about? So the linked data is all about, it is nothing but it is a practical application to the real world data. Here we used to write the data, or we used to structure the data in such a way that we used to publish it and interlink all the entities that are present in the data, and we used to publish it on the web, so that if any information is present, it can get connected to the other information. I'll show you in more detailed manner in the further slides. And if we talk about the linked data principles, basically there are the 4 linked data principles that we need to take care of while developing the linked data. So the first thing is, if we want the web of data, as we have said that our main focus is the data. So it means those can be the persons, those can be the organization names or the things. So here we used to use the URIs so that we can identify this particular data with the URIs. And to do that, we use we must also use the HTTP URI so that the people can see and look up those names, what these particular names are all about and what information does it tells. So URI should provide useful information using the standards. So there are some standards regarding the semantic web that we will discuss in the further slide, what the standards are all about and how do we achieve those standards. And it also should link the other URIs, means our URIs with the other URIs, so that it can discover the more things. For example, if there is any person named Bob, and the Bob is nothing but the entity in the web. He is the data in the web. So if we want to get any relation to that regarding that particular person, it should have link to its friends, means who are the friends of that particular Bob, and what are his daily habits, or what does he used to do on the internet, what are his interesting subjects. So we can find all these things using the web of data. So for that, we require the other URLs also to get included in our data so that we can infer that knowledge. Now, this is regarding how do we connect the data, means how do we interlink the data, which is called as linked data. But now we will talk about what is linked open data. So basically, when we where the linked data and the open data come together, it is nothing but the linked open data. So here, linked data, we have already seen what is the linked data. The entities that are there in each and every data, they are interlinked, and we are making it open to each and everyone, so that each and every person, whether it is a human or whether it is a machine, they can be able to use that data. So that is nothing but the linked open data. So there are different publishing ways how do we use to publish this linked data. So, and when we are saying that it is open data, it must have the open license, which intends that it is freely available to each and everyone, and it can be republished without any restrictions, whether it is a copyright, patent, and other restrictions. And when we talk about the linked open data, if we are uploading or if we are publishing our data, we can, whatever the data that is present already on the web, we can add more data into it without disturbing the original data source. So open environment is nothing but linked open data is nothing but it is also called as an open environment, where we have the scalability, we have the openness to the data, it is freely available, and it can be published wherever with some additional knowledge. So to achieve the linked open data, there are some principles, or we can say that linked open data has 5 stars, means it tells whether your particular data is the linked open data or not. So if we start with the first star, the first star is nothing but your data should be the open license. It should be open for everyone, doesn't matter whoever it is. It should be fully open on the web using the open license. Now, if your data, if the data is in the if the data is open, then it should be able to the machine should be able to use that particular data. So the second star will be applicable for the machine readable format, whether your data is only available for the human consumption or the machines can also use it. If the machines can also use it, then you can have the 2 stars, means your data, means with the open license you're also providing the data with in the machine readable format. Now after that, the data must be provided in the non-proprietary format. Non-proprietary format is nothing but where no one is having their own standard. The standards are open to each and everyone, like the CSV or the text file or the images PNG in that way. So with the 2 stars, open license and machine readable, it should be also available in the open format. Now, if these 3 stars are there, there are 2 more stars that are required to see whether our linked open data is a 5 star or not. So to achieve the 4th star, it should have the URL. That is, the people must be able to identify the things using the URLs. So as I have told earlier, that URIs are nothing but those are the W3 standards like we used to have. So this particular URIs used to tell us that what are the names and what are the things, and it used to give us the more information regarding the data. And the open standards, the open W3 standards are RDF and the Sparkle queries that we used to use to access such data. And the fifth star will be, if we are providing our data openly on the internet, it should link to other data also. So linking the other data which is already present is also very important when we are trying to publish the data on the web. So these are the 5 stars which will tell whether our linked open data is completely linked open data or not. And the fifth star that we are talking about, it will evolve by the time. Means as if we will publish the data, how many people are reusing it, it basically depends on that. Means how our data is being used and how many times it is being used. So I hope that we have understood what is the semantic web, what is the linked data, and what is linked open data. So now we will talk about the semantic web tech stack. This is the small web layer cake, which where means this is how the semantic web is designed. So basically, the you can see that from, if we come from top to bottom, the very first layer is for the applications and the services. It is nothing but the users that used to use the data or the machines. And the second layer is about the trust. So whether the particular data that is there, the particular application is using, whether it is trustable, verifiable or not. So if it is trustable, what is the proof of that? Means basically proof is nothing but the foundation of the trust. And then we have the transmission security like cryptography, which is used for encrypting the data. And also it used to provide basically it is used for encrypting the data so that it should have some security concerns. And then then there is the unifying logic, where we will see the first order logic. Means the first order logic examples in the English, in the simple English language, are nothing but the keywords like if and the Boolean operations, the sum, even, all this first order logic components. Then there are the rules. Basically, these rules are nothing but it tells about how we can infer the knowledge from the particular data that we are providing on the semantic web, that we provide on the semantic web. So how we can get the knowledge? So we need to write the rules for that. To access the data, we can write the queries in the form of Sparkle or SPASQL. And dictionaries are nothing but the ontologies, or we can call it as a vocabulary. Means the vocabulary tells about it tells about what is the definition of the data, what this data is all about. Means it is nothing but the metadata of the data. And then the abstract language is nothing but the RDF format. So RDF format is nothing but it is the data which is represented in the form of a triples, subject, predicate, and object. So whatever the data that we have, the language of that particular data will be in the RDF format. Then the sentence part identifiers, which is very common, like the HTTP IRS and URIs. And the document type, as I have told you, we require the open format document types like the RDF, JSONs, XML, Turtle, and triples in this way. And then the last layer is nothing but the semantic web of linked data, where we are having our data. So this is how the tech stack works if we want to get the data from this linked data to the application. Now, if we want to talk about what basically linked data, as we have seen in the very first picture, there was a very big graph, the dense graph. So what that graph is all about. So previously means we are still using this thing. We have heard the thing like the relational databases, the key value databases, means NoSQL databases. And now there are the third thing, that is the graph databases. So as we can see that there are various ways of data storage and management. So if means we have already used this thing, relational databases, where we are having the tables, and the tables are having the data inside it. In each the instances are nothing but the rows that are filled in the data with the attributes as the columns. So if we want to get any information, there are we require complex connectivities between the tables. So we used to call it as a join tables. So here in the relational databases, if we want to write the queries will be very complex if we have the more number of particular tables. And the schema is nothing but the structure of the data which is rigid. That is, in the relational databases, we can only format our data in the form of tabular format. So even though it gives us the high performance for the transaction, but it also gives the poor performance for the deep analytics. So we cannot infer knowledge, or it's not like we cannot infer knowledge, but it gives us the poor information that we cannot do the much analysis on the relational databases. And then there are NoSQL databases, means the key value databases, where we need to have the multiple scans throughout the for the whole data that are required. Even though the schema is fluid, or we can also call it as a no schema, because it is having only the two values, the key and the value. It also gives us the high performance for the simple transactions, but it is still gives us the poor performance for the deep analytics. Now there comes the graph databases. So here the graph databases, the picture itself is explainable. That, for example, if there is an order, it tells us that if whether the payment is accepted, who purchased it, what is the location, means where we need to ship that particular order, where it is coming from, and how to notify the supplier. So here you can see that all the particular nodes or entities related to that particular order are connected to the order entity. So here the schema is flexible. Now, what is the meaning of a flexible schema? For example, if we talk about the relational databases and the graph databases as a comparison, in comparison between the relational databases and the graph databases, if we have a data which is having some extra attribute or some extra value or some new entity, we can call it as a new entity. So if we talk about the relational databases, there we will require a whole column for that new instance, where it will have the new attribute value. So the previous data will not have that value. The column, that the particular value for that particular data in that column will be the empty one. And means the thing is, we will have to add the columns according to the attributes that will get added. Okay. And then here in the graph databases, if we want to add any new attribute, what we require is, we have already the entity, we can just add one node and we can connect that node with that particular entity. So here the schema is flexible. It also gives us the high performance for the complex transactions, and it also gives us the high performance for the deep analytics. As we can see that all the links are interconnected, so it can be used for inferring the knowledge also, and for the reasoning purposes. So this is what we have talked about regarding what is the semantic web, what is the linked data, and what is linked open data, and how the semantic web tech stack works.
Pooja?
Yes, ma'am.
You people can hear me now.
Yes, ma'am.
Okay. Hello everyone, this is Sarika Jain, and before going the way forward to case study, Pooja, I will like if we could interact with the audience, we could interact with the participants sitting here, because I could see your module 1 is about to finish.
Yes, ma'am.
So if till now, before explaining the case study, if we have some discussion, Dr. Nandana may like to add upon some slides if he wants. And if the audience have some questions for this module 1, please go ahead. And let us make it an interactive session so that everybody could get the best out of it.
Yeah, I think we have plenty of time. So if you have any questions, I think you can ask then and there. So we can make it more interactive.
Yes. Okay, so either Pooja has explained very well, or the audience really do not have something or anything to ask by now. I hope when the case study will come, then more interaction will be there and required also. So I hope you continue with the case study. So in module 1, I hope you will be giving an overview of the case study that we are going to take for today. And Pooja, if possible, if you could scroll through the publication that we have written, the work that we have written and submitted, we will be putting it to the preprint also, and we can circulate it amongst the participants also by tomorrow if possible. So you could scroll through the paper also so that everybody have a look of it. First of all, please go through the case study brief. Yeah, over to you, Pooja. Back.
Thank you, ma'am. Just So now we will start with the case study of our project, that is the Oligraph, the Olympics link data. So before we go with the demonstration of how the site works and how the application works, I would like to show you the application architecture diagram of the Oligraph. So here, this is the application architecture of the Oligraph. These means how this particular web application has been created. So the very first layer, we will start from the bottom to top, where the data acquisition is the very first layer. So on the left hand side in the green, these are the layers, means what, and in the blue means the part which is there in the blue is how, what means how do we achieve that how do we achieve the topic that are there, how do we achieve the tasks that are there in the layers. Okay, so the for the data acquisition, we have gathered the Olympics data from the Kaggle. So as we know that Kaggle is the platform where most of the data sets are published for the research, for the analytics to use it, or for the domain persons to use it. So we have got our Olympics data from the Kaggle. We have downloaded that data. Then for inferring the knowledge, means how the Olympics works, how we used to store the data, how the Olympics data needs to be modified or it should be linked. We have referred the Olympics site also, that what kind of data is present on the Olympics website, how they have represented the data, and what kind of information they used to show. And then we are using some existing vocabularies as nothing but the metadata, which will tell regarding our data, that it is nothing but metadata for our data that we'll be using if there are any existing vocabularies. And we have also made use of the Wikidata for inferring for the data acquisition layer. So once we gather all this information, we will shift, we will head towards the second layer, that is the metadata formation. So as there were no metadata already present for the Olympics project, the schema was not already present. So we need to build our own schema. So for building our own schema, we have gathered whatever the knowledge that we have gathered in the data acquisition. We have used that knowledge. We have decided what will be the classes, what will be the object properties and the data properties. So object properties are nothing but how one class is connected to another class with what property, and the data property is nothing but what kind of the data that particular class will store or that particular entity will store. So in this way, we have created the metadata in the second layer from bottom to top, and we called it as the Olympics ontology or the Oligraph. So after creating the metadata or this schema for our Olympics project or Olympics data, then we will head towards the third layer, which is nothing but the data storage and management. So here, as we are working on the for the semantic web data, means we are our particular motivation is the link data and the link open data. So what we are doing here, whatever the data we already have in the form of CSVs, we have converted the data, we have linked that data, we have made some cleaning. Cleaning is nothing but if there are any null values present, we will fill those values with some mean and average, and then we will map our particular data using the metadata. Means what will be the relation between the entities or the instances that are present in the information or in the data set. So after creating the linked data, so this particular 3 stack rectangles are nothing but what are the things that we are doing to create the linked data. Now, once the linked data is created, we are uploading it on the web via either via either the linked open data or in the form of RDF dump or in the form of the URIs or we can also store it in the triple store. So triple store, as we know that we know that MySQL, Workbench, and this particular databases are nothing but the relational databases. In the same way, we also have the triple store which used to store the RDF format data. And after storing the data and after publishing the data, we require the access point. That is how we can access that data that we have stored. So for that, we have used the Sparkle endpoint. The Sparkle endpoint is required for the triple stores if we are storing our data inside the triple store, and we also require the API, the access point information. So in this way, we have the fourth layer will be from bottom to top. The fourth layer will be the how we will access the data via basically the Sparkle endpoint. And then these are the applications. Means as the data is coming from bottom to top, if we want to get the data, so what means in which way we can get the data. Means for example, the applications will be the athlete use cases, the sport use cases, the country use cases. Athlete use cases are nothing but how many athletes are there for this particular Olympic sport, or what is the average age of the athletes for this particular year. So these are nothing but the use cases. And if we want to talk about the country use cases, so how many countries have participated, for example, in the specific year 2012 in the Olympics, and which particular country has got the highest medals. So these are nothing but the use cases regarding the country. Then the sport use cases are nothing but the use cases regarding the sports, like how many sports are there, whether the particular sport is a multi-event or a single event, or if it is a multi-event, then what kind of events that are there and who has participated in that event, and so on. And then we are also having the oligraph visualization, like how our data looks like if we have converted it into the form of the knowledge graph. Then the question answering. So for example, question answering is nothing but if we write any particular question in the form of natural language, means which particular athlete has got the highest medal in 2013 Olympics. So this is the natural language question. We will identify the entities about which athlete it is talking about, or what is the scenario, means what kind of the question the user is asking, and then we will give the answer from to that particular user's question using our data. And then we have the developer query service. Developer query service is nothing but it is basically useful for the developers, so they can write the different Sparkle queries and they can extract the data from the triple stores. And then we also have the metadata visualization, like what are the classes, what are the object properties, and what are the data properties, and how the metadata is created. So the end users for this particular applications are nothing but the data analysts, the application developers, the sport enthusiasts. If as people love sports very much, so if they want to find any information regarding their particular favorite athletes, they can find that information. The sports experts can also use this particular website for some analysis or for the performance of the different athletes from the different countries, and they can draw their particular roadmap that how they can better their performance. So in this way, this application is useful for different users, and that as the data is the linked open data, so any application developer can directly use that data also in their own application, and they can add more data to it, and they can infer the knowledge. So now what technologies we have used to achieve this particular web application? The first is, if we will start from the bottom to top, the data acquisition has been done with the help of Python programming language. Then to create the metadata formation, we have used the OWL. OWL is nothing but the web ontology language, like we will give the hands-on on OWL, that how do we create the OWL. So Protege is the kind of a software which is used to create the ontology, and ontology and Vidopo are nothing but the documentations which we have provided for our metadata formation. And using ontology and Vidopo, we have created the documentation for our ontology. That is metadata formation. And then for storing the information, we use the Python. For the first thing is, for creating the link data, we have used the OpenRefine. And for connecting the front end with the back end, we have used the Python. Then for writing this to execute the query, like for example, if anyone wants to find that what are the top 10 athletes, so if he clicks on that particular button, the query should get fired and it should retrieve the data from the triple store, and the result should be displayed to the particular user. So how we are connecting this particular application layer, data access layer, and data storage layer? We are using the Django Python and the SPyCall queries to retrieve the data from the triple stores and show it to the user. And then the front end of this particular application has been created using the HTML, Tailwind CSS, and the Chart.js. So this is regarding the application architecture of the Oligraph web application. So
before you move forward, I will like to take 1 minute on the same slide. Please come in present mode.
Yes.
This is for the participants. Yes, as Pooja has already explained, the various layers of the architecture that we have worked upon for Oligraph. And we could map the 4 modules that we have brought in for this tutorial with this architectural diagram in a manner that module 1 that has already been covered was a motivation of linked data. Why do we want linked open data? As a motivation for semantic web. To achieve semantic web vision, we want to have linked data. And if you could see the second last layer, metadata. So the module 2 will be metadata management and creating the metadata. That is how we came across the Oligraph ontology, how we created it in Protege, and how we published it. Then comes data storage and management. Here we discuss about the data, the RDF data that has been stored and queried upon, based upon the metadata, based upon the ontology that we had already created. Then comes data access. This is module number 4. We are querying the data using SPyCall query. Yes, Pooja, please go. Yeah, Pooja, you could proceed further.
yes, thank you.
Okay.
So to give the short demo regarding our application, we have hosted our application on the Heroku server. So how we have hosted it, what are the things that we require for hosting the particular web application, that will be discussed further in the 4th module of this tutorial. So this is how the Olympics knowledge graph looks like, the Oligraph website looks like. These are the SPyCall endpoints that has been given to query the data for the remote for the developers. And the question answering is under still progress, where the people can write the questions in the normal natural language, and we will extract the entities and we will give them the relevant answer to whatever the question that they have asked. So this is how the site looks like. Now these are the use cases that I have already talked about, like we have the athletes, country, sports, SPyCall endpoint, and the ontology. So if we see regarding the athlete, so these are the use cases that we have. So if we want to find out the top 10 athletes by the medal count, you need to click on that use case and it will retrieve you the information related to the same. Just a second. So the top 10 athletes are nothing but the Emma McCann with the 7 medals. So in this way, you can get the information regarding the top 10 tallest athletes, 10 heaviest athletes, 100 oldest athletes, 10 youngest athletes in this way. So now you can see that it is retrieving the information regarding the tallest athletes. So these are the use cases that are there for the athlete class or for the athlete. And then if we want to talk about the country, so these are the use cases that we have for the countries, like what are the top 10 countries by the medal count. So you can see that United States is the top 10 countries, then top 10 countries with the male athletes, still US is the country with the top 10 male athletes. So now if we want to find out any country with some specific country name, we can do it in this way. So for example, India. So you can also see the country athletes, country statistics. So in this way, the average height, average weight, and average age for all the participants that have participated from India in the Olympics, it has been given. And now regarding the sports. So for the sports, we have the use cases like all sports, then the events in the sports and the top 10 players of the sports. So if we want to see the top 10 players of the sports, so which sport that we would like to see. So if we just click on the gymnastic, it will tell us the top 10 players in the gymnastic. So in this way, it is retrieving the data. And now regarding the Sparkle endpoint, here we can, this is basically provided for the developers, so that they can write the different queries and they can extract the information from the database. So here, this is a small Sparkle query. You can see that these are the prefixes. RDF and RDFS is nothing but the schema, and RDF is used for the syntax. As we know that the data that we are storing, it is in the RDF format in the form of triples, subject, predicate, and object. That is why it will always retrieve it in this way, subject, predicate, and object. And we already know that select star means select the whole information that we want, and the limit is 10. So for example, if I just run this particular query, so the SQL queries and the Sparkle queries are somewhat similar. There is not much big difference between how we write the SQL and the Sparkle. So this is the Sparkle endpoint that we have used. This Sparkle endpoint has been created using the triple store, which is known as the Jina Fuseki server. Okay, so you can see that these are the URIs of the particular athletes. This is the predicate, like participated in, and in which sport they have participated. So in this way, we are getting this data. As we have limited to only 10, so we are only getting the 10 results from the database. So in this way, this is regarding the Sparkle endpoint. We will cover this particular Sparkle query, how do we write it, and how it extracts the knowledge from the triple stores in the 4th module. And then this is the ontology. This ontology is nothing but what are the classes, what are the object properties. For example, if we have the athlete, that it has a gender, it has nationality, it has participated in which sport. So in this way, these are the object properties and these are the data properties that we have. So this is nothing but the metadata that we have created for the Olympics project. So before I start with the second module, if anyone wants to ask anything or any query regarding the first module, then we can have it.
Yes, the participants are motivated to unmute themselves and go ahead with the questions if they have. If I look
yes, ma'am. I just have a small question.
Shikha,
Yes, ma'am. That since you are using the Kaggle dataset, so I just wanted to know what were the basic or the initial fields that were there in the Olympic datasets, and secondly, what kind of processing, the pre-processing was done using the NLP techniques.
Okay.
Yes.
Okay. So I will take your question, Ms. Shikha.
Thank you.
Actually, this is module 3 of the tutorial. We will
Yes,
go
ma'am.
through the ontology development in module 2, and we will be going through the RDF dataset development in module 3. In module 3, we will explain how we took the data from Kaggle, what were the various fields for the Olympics data, and which tool we used to convert it into RDF and publish it on the web. I hope.
Sure, ma'am. Sure.
Then.
Yes, ma'am. Sure.
Yeah. Okay. Thank you.
Maybe we can take Valentina's question as
Yes.
well, as we are in. Pooja, if you can go to the slide that you had, the Semantic Web 1, 2, 3 explain.
Yes, sir.
May I speak the question out? The question.
Yes, please.
The question of Dr. Valentina is: can you point to the time frame of the phases of the semantic web? Are we still in semantic web 3.0? Maybe overlap with semantic web 4.0? What about the semantic web 5.0? Yeah, Dr. Nandana, over to you.
Yeah, I think the timeline in general is like, I think we consider like from 1990 to 2000 as Web 1.0 and 2000 to 2010 as the Web 2.0 and 2010 to 2020 as Web 3.0 and beyond 2020 as Web 4.0, and then the Web 5.0 will come as well. And in general, yeah, these overlap with each other. So it's not that when Web 2.0 comes, the 1.0 dies. So they live. We have legacy applications. So they overlap a lot. Like we see a lot of Web 3.0 applications as semantic web still out there, like things like DBpedia, semantic search, and a lot of e-commerce applications that are based on semantic web are already there. It's quite popular. So they overlap a lot. And I think Web 3.0 would live for a long time also, but there are new things coming. So right now what is popular is like these things like digital twins, Internet of Things. So these are getting very popular, and a lot of small devices are getting connected to each other, and then they work intelligently with each other. So this is what is happening right now. And then I think the Web 5.0, which is Web of Thought, is still in the philosophical level. We are kind of exploring what we can do in Web 5.0. Does that answer your question, Dr. Valentina?
Yes, thanks a lot. Thanks a lot. Yes, it was really fine that we have this slide in the very beginning, just to know where are we now. And so thanks a lot for the question and for the explanation.
You're welcome. Yeah, I think we should mention where we are now. I think in the coming presentation, we will highlight what's kind of what is the current stage and what's the future.
Yes, thanks.
Yes, audience, we are already open for the discussion. If there are any more questions, please go ahead. Yes, I could see one in the chat box from Abhishek. He wants to ask, could you please put some light on the thought process when choosing the set of tools or language or library for the development? Okay, Dr. Nandana, will you like to take it over? Abhishek, you couldn't unmute yourself, I suppose. Your mic is not working.
Yeah, so just to clarify, when you say the set of tools and languages, it's when we are building linked data applications. Are you asking the set of tools and languages when we build linked data applications?
Abhishek, you could mention in chat box, are you talking about linked data application or all together? Because every type of application we are building, we will have to choose based upon the type of application we are doing.
So I can answer, assuming that it's about linked data applications. So I think we will talk about a lot about different tools and how this whole process is done in module 2. But if we want to just talk about the languages, I think we might talk about the languages here. So for semantic web and linked data applications, there's a standard body called World Wide Web Foundation, so which actually standardizes most of these languages. So these are worldwide international standards. So things like RDF, all, and all these other semantic web stack that we were talking about. So for the languages, there's a de facto international standards for using that. About tools to use for building linked data applications, I think we will discuss a lot more in module 2 and the coming up module.
Yeah, in addition to that, here is the tech stack, Abhishek, that we have used for the Olympics application, which is again a linked data application. And we will take you towards how each one of them have been used for creating this application in rest of the 3 modules. Module 1 has just been an introduction to what we are going through. From Prateek Srivastava, we have a question. If as an analyst, I need some data for analysis, then how to find that from your web? Will it provide any API or JSON file?
So for that, I think it kind of depends on like what kind of richness of the data that you want. So if you want data in RDF and linked data formats, we have something called linked data cloud, which kind of aggregates data sets from all over the world and put them into a single catalog. So that provides an overview of whatever available data on the web in linked data in RDF in a semantically rich manner. But then also, if you are interested in more open data in other formats that are not semantically annotated, like JSON data, CSV data, there are like a lot of open data portals available in the web that you can search for the kind of data you want, even like the Kaggle data sets. So depending on the data you want, depending on the domain and depending on the richness of the data you want, I think there are different portals that you can look for data. Maybe Dr. Jain, you can add a little bit as well.
Mr. Prateek, I hope you wanted to ask the same general. Was it a general question that how to find out data on the web, or if there anything specific you could mention, please?
No. At the your users level, I had seen that for the end user, we can get the data for the analysis also. But I'm looking for analysis from your web, the proposed web that you have created here, that you have shown in the chart.
Yeah.
The same chart, yes. At the top level, see there is mentioned data analysis. Suppose an end user, I am looking for the data for this data analysis for any of the case, like athletic use case, country use case, any of the case. Suppose I'm looking for data for my own work, then this proposed work will provide us data or not?
Yes, definitely. That is a very good question and we appreciate it. Yes, the data we will create in module 3. In module 2, we are creating metadata. That is also available. Pooja, if you could go to the ontology documentation. In module 2, we will be creating metadata and that is available here. Pooja will just display. And in module 3, we will be creating the linked data. that will also be available on the web. This is the ontology that is available on the web and anybody could use it. That is the beauty of linked open data. It is open on the web for everybody to use. So one application, this has been developed just for demonstration purpose. We have used that data. Plus we have provided a Sparkle endpoint. If the end users directly want to query the data, they could query it from this Sparkle endpoint. Otherwise, they could develop their own APIs to get the data in whatever way they want. So the Kaggle data that is in CSV format has been converted to linked data, has been converted to RDF format, and it has been published on the web on the linked open data cloud that is open for even the data analysts to use. So it is available over the web. We will take you through it in the module 3. It is available with you.
Okay, ma'am. Thank you.
Okay. And one more point to add here is as a difference between module 2 and module 3. What we are saying is in module 2, we will be taking you to ontology development, that is metadata development. And in module 3, it will be data development. So what is the difference? The difference stands in layman language. If we speak about, then everybody is aware of RDBMS. So in relational databases, everybody create tables. In tables, we have a schema first of all, and then we populate the data. So we have DDL and we have DML, data definition language and data manipulation language. Through DDL, we are creating the schema. We are creating the metadata, that is the table headers. That is the ontology, means module 2 with us. And the data that you insert into the tables, that you manipulate using DML, the select query, you access the data, that is DML, that is module 3, means RDF data that we will be talking about in module 3. I hope it makes sense to the audience, and if really you have something more to ask, please go ahead. We are happy to answer. I have a question from Ankush Bisht. We are okay, this is not a question. Ankush Bisht is one of the developer, one of the authors of this, and he's saying we have provided Sparkle endpoint for developers as well. Yes, that is what I just told. Even Sparkle endpoint is there. For example, here is the Sparkle endpoint, and from here you could query and get the data. Any more questions? We are open for it. Okay, I hope Pooja, we could proceed further, and then after module 2 is done, we will open the next set of discussion.